We use it every single day, right? But have you ever stopped to actually wonder how our digital world really connects? Well, today we're going to pull back the curtain and demystify the magic of telecommunications.
Think about it. You snap a photo on your phone, you text it to a friend, and a second later, bam, it pops up on their laptop, maybe thousands of miles away. How in the world does that happen? How does an image or a video or just a simple, hey, travel across the globe in the blink of an eye? That's the journey we're going to follow.
So, to really understand that photo's journey, we've got to start with the one big idea that makes it all work. Let's start right there. What even is telecommunication?
Okay, so that's the official, super technical definition. It covers pretty much everything from the old school telegraph all the way to the fiber optic cables we use today. It sounds really complex, I know, but the basic idea behind it is actually incredibly simple.
Yeah, if you strip away all that jargon, that's what we're left with. It's all about getting information from point A to point B. The best way to think about it is like a massive global superhighway system that was built just for data. But, before our information can hit the road, it has to get packed up for the trip. So, how do we get our data ready for this big journey? I mean, you can't just shove an entire high-resolution photo onto the information highway all at once. It's way too big, it's clumsy. The system needs a much, much smarter way to handle it. So instead of sending it whole, imagine your photo is like a giant jigsaw puzzle. The network does something amazing. It basically shatters that puzzle into thousands of tiny, easy-to-manage pieces. And it's way faster and more efficient to send all those little pieces than it is to send the one giant picture. Now, these little pieces have a name. They're called data packets. And they aren't just random chunks. No, each packet is a smart piece of the puzzle. It carries a little bit of your photo, sure, but it also carries the destination address. It's like a tiny digital envelope. These are the individual cars that are going to get on our information highway. And here's the really cool part. These packets, our little cars, they don't even have to take the same route. They can all zip across the internet on different paths to find the fastest way there. Then, once they all arrive at the destination, your friend's laptop knows exactly how to reassemble them in the right order to recreate the original photo. The puzzle gets put back together perfectly.
Okay, so our data is broken down into smart little packets, all ready for their trip. But what is the road itself actually made of? Well, for our phones and mobile devices, that first part of the highway is completely invisible. It's made of radio waves.
So if the network is a highway, then you can think of frequency as the specific lane your data packets are driving in. We need different lanes for different kinds of traffic, AM/FM radio, your home Wi-Fi, your cell signal, and that's all to make sure that everything doesn't just crash into each other. Your phone and the cell tower agree on a specific lane, and that's how they talk. And these wireless highways have gotten so much better over the years. Think of 3G. That was like the first real on-ramp to the mobile internet. Then 4G came along, and that was a massive upgrade. It was like widening the road to multiple lanes, which is what allowed for things like streaming HD video. And now there's 5G. That's the brand new superhighway built for insane speeds and connecting everything from our phones to our cars. So we've got our highway, we've got our lanes. But how do we actually measure the flow of all this traffic? Well, this brings us to two really important ideas that are absolutely key to understanding how your internet works, but honestly, they get confused all the time.
Okay, let's clear this up. On the left, you've got bandwidth. This is the potential of the highway. Think of it as how many lanes the road has. A 10-lane highway just has more potential, more bandwidth than a 2-lane road. Simple. But on the right, we have throughput. This is the actual speed you experience. This is how many cars are really getting through during rush hour, which can be affected by traffic jams or, for us, network congestion.
And this visual just makes it crystal clear. Your internet plan might promise a certain amount of bandwidth, that's the 100% potential, but your actual speed, your throughput, might be a little less because, other people are using the network too. So the key takeaway here is, bandwidth is what you pay for, but throughput is what you actually get. So then, what about when you hear the term broadband? What does that actually mean? Well, it's pretty simple. It just means you have a connection with a very wide bandwidth. It's really just the official name for a big, multi-lane information superhighway that has enough capacity to handle tons of traffic at really high speeds. All right, we have all the pieces of the puzzle now. We've got our packets, frequencies, bandwidth, and throughput. So let's put it all together and trace that one photo's complete journey from your phone all the way to your friend's screen. So the moment you hit send, here's what happens. First, your photo is shattered into thousands of those little data packets. Then, those packets are beamed wirelessly from your phone over a specific frequency to the nearest cell tower. From there, they hop onto the 5G superhighway. The total size of that highway is its bandwidth, but the real speed they're traveling at is the throughput. And finally, after that whole trip, all those packets arrive at your friend's device and are instantly put back together into the photo you've sent. That entire process, from start to finish, that's modern telecommunication.
So the next time you send a message and it just appears instantly on the other side of the world, you'll know it's not actually magic. It's a ridiculously fast journey along an invisible highway made possible by packets, frequencies, and bandwidth. And that really just leaves us with one last question. Now that we have this incredible system in place, what are we going to connect next?